Section 7.3 is all about simplifying radicals, the distance formula, and circles. Ooh, circles. So here's the product rule for square roots. So if a and b are real numbers and n is a natural number, then it's always true that the nth root of a times the nth root of b is an nth root of a times b, i.e. the root of a product is the product of the roots. So for example, if I had the square root of 2 times the square root of 3, that answer would be the square root of 6. And you can check that in your calculator if you want. But yeah. So if I have the square root of 5 times the square root of 7, that becomes the square root of 5 times 7, which is the square root of 35. And as always, check and see if you can simplify these radicals. If I have the square root of 11 times the square root of p, that becomes the square root of 11p. Notice they always have to have the same index. If I have the cube root of 3y times the cube root of 12z squared, that becomes the cube root of 36. 3 times 12 is 36. Y z squared, and make sure you put your index in there. And I always want to write my variables in alphabetical order. If I have the 6th root of 10m to the 4th times the 6th root of 5m, that's going to be the 6th root of 50. 10 times 5 is 50. M to the 4th times m, that's m to the 5th. And I can't simplify any of those any further. We also have a quotient rule for square roots. I have demonstrated this before. So if I'm taking the nth root of a over the nth root of b, the nth root of a over b, I can distribute that radical in the numerator and the denominator. So the nth root of a over the nth root of b is what that becomes. So I think the example I did before was if I have the cube root of 8/27, that becomes the cube root of 8 over the cube root of 27, which is 2/3. So let's work through some examples. So if I have the square root of 49 over 81, that becomes the square root of 49 over the square root of 81, which is 7/9, and I can't simplify that fraction any further. If I have the 4th root of 81, 16ths, that becomes the 4th root of 81 over the 4th root of 16, which becomes 3/2. If I have the square root of 6/49, that becomes the square root of 6 over the square root of 49. So I have the square root of 6 over 7. I can't simplify that any further, and that's okay. And if I have the cube root of -8 over 125, I would get in the habit of taking the negative with your numerator. So I have the cube root of -8 over the cube root of 125. So I'm going to have -2 over 5. So -2/5 would be my answer. When it comes to radicals, one thing that we want to do is get really good at simplifying them. I don't mean like plugging in your calculator, because remember, if I was to take the square root of any number that's not a perfect square and you plug that into your calculator, you're going to get an irrational number, right? That's a number that cannot be expressed as a fraction. It goes on and on. Sorry, cannot be expressed. Yeah, it cannot be expressed as a fraction. It goes on and on forever. But one thing we can do is simplify them. So remember, we want to keep our answers in radical form, but we can simplify them. So for example, if I have the square root of 20, what we want to do is we want to factor the radicand. Again, that's what's under our radical, and find the square. So I have 20, which is 2 times 2 times 5, which is 2 squared times 5. I'm going to put that under the radical. So I have the square root of 20 equals the square root of 2 squared times 5. And then kind of using the reverse of our product rule, I can pull that apart. So that would become the square root of 2 squared times the square root of 5. Well, squares undo squares, so I'm left with 2 square root of 5. So we would rewrite and simplify the square root of 20 as 2 square root of 5. And now that we know how to do this, I expect all radicals to be simplified on exams and in the homework. So let's work through this example. I've got the square root of 24. Well, 24 factors into a 2 times 12, which is a 3 times 4, which is a 2 times 2. And I want to collect the squares. So 24 is 2 squared times 3 times 2. So I'm going to rewrite this as the square root of 2 squared times 3 times 2. So I could rewrite this as the square root of 2 squared times the square root of 3 times the square root of 2. Well, the square root of 2 squared is the square root of 4, which is 2. Then I have the square root of 3 times the square root of 6. We can use, 2. And I can use my product rule to rewrite that as 2 square root of 6, because the square root of 3 times the square root of 2 is the same as the square root of 6. Let's work through some more examples of simplifying radicals. So if I have the square root of 108, the first thing I need to do is factor that. So I have 108 factors into a 2 and a 54. 54 factors into a 2 and a 27. 27 factors into a 9 and a 3. And 9 factors into a 3 and a 3. So I collect the squares. So I've got square root of 108 is equivalent to the square root of 2 squared times 3 squared times 3. So I can pull this apart. The square root of 2 squared times the square root of 3 squared times the square root of 3. And again, as you get more comfortable, you don't need to rewrite this out step by step like I am doing. Just however helps you stay organized best. So that gives me 2 times 3, because square roots undo squares, times the square root of 3. So I have 6 square root of 3. That is square root of 108 simplified. Next, 2 is the square root of 15. 15 factors into a 5 and a 3. There are no squares there, so this is fully simplified. For example 3, I have 16. 16 is 2 times 2 times 2 times 2. So I'm not collecting squares now because I'm taking the cube root. I'm collecting groups of 3. So this becomes the cube root of 2 cubed times the cube root of 2. So that gives me 2 cube root of 2. Next I have the square root of 16. Well, let's pull that apart a little bit. So the square root of 16 times the square root of m cubed. The square root of 16 is 4. So I have 4 square root of m cubed. M cubed is m times m times m. I'm taking the square root, so I collect the squares. So I have 4 square root of m squared square root of m. So that would give me 4m square root of m is our fully simplified version.